Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to everyone. Welcome to our 7th class for DCE 6953, which is multivariate statistic for social science. And currently we have 16 students attending the session. And for those who are registered, please make sure sign in for your attendance. I have already posted the attendance form, the Google form, so just fill up the form and simple form, inshallah. And we have already completed our discussion on multiple linear regression the week before Hari Raya. And for today, we will be going for the next topic, and this will be the last topic for to be included in our midterm exam. Okay. I want to capture our picture for attendance. So as much as possible, please switch on your camera because I want to capture the attendance based on the hasil Linda tengah makan. Tak apa, teruskan. Tempat masing-masing. Okay, the rest, please switch on your camera. I want to capture our picture. No response. All right. Few more. Okay. Nah, hasilnya dah ready tu. Tersabar dulu. Kita akan bagi tahu bila kita nak tengok gambar ni. We have two of our friends who still didn't switch on the camera yet. Okay. Okay, get ready. 1, 2, and 3. Okay. Do you have another panel or just one panel? Because the number is not as many as the other class. Oh, we have only one panel, one panel to cater for all our students in this subject, inshallah. As we mentioned the week before Hari Raya, we used to have about 50 students, and even there are cases whereby students want to join for the class, who want to register for the class, but they cannot register because of the maximum number has been fulfilled. But now until today, I just opened the attendance list issued by graduate school. The number of registered students, the latest number is still 17. So we hope that it will retain, it will not reduce further to a smaller number. Okay, so what we intend to do this afternoon will be, we are going to discuss the last topic to be included in the midterm exam. And our midterm exam, inshallah, will be scheduled for next week. Our midterm exam will be scheduled for next week, class time. That means 2 to 5 o'clock. Class time next week. Today is the 12th, so our exam will be on the 19th of May, and the topic to be included will be from the beginning until partial correlation. I mean, that will be the topic to be included in our midterm exam, and I'm sure if we have done our assignment on your own, and you have gone through the learning material, the exercise, the calculation, everything, I would be able to foresee that none of you have any problem to work on your midterm exam. Are you ready for the midterm exam, Faizah? Dah ready kan? But last semester 5950. This semester just extension to 5950, which is multivariate statistic, inshallah. And we have ample time to work on the exam because this is not this week, but will be inshallah next week. After Hari Raya, after you have taken your lemang, after you have taken your ketupat, after you have taken all whatever that you want to take for the during the festive season. So now we are ready. Yeah.
My son caught with COVID.
Oh,
sorry, Prof.
Kena COVID?
Yeah.
Bila? Sekarang ni?
Before Hari Raya, my daughter caught with COVID. She came back from hostel. And then my son day 1 yesterday.
Tapi your daughter recovered lah.
Dah already recovered. Dah balik hostel dah.
InsyaAllah, Alhamdulillah. So we hope that your son will also recover very soon. So itu dia masuk hospital ke treatment kat rumah je?
No. House quarantine je because dia punya symptom is very mild je lah. Cuma first day ada fever sikit and then sakit tekak.
Oh tu. Tapi ni how do you know that dia dapat dia kena COVID-19 tu? Gunakan test kit tu tak?
Test kit, we using RTK. And then we monitor oxygen level using oximeter and temperature lah.
Yeah. So any specific medicine yang dibagi? Dia tak ada ni kan, tak ada.
We just we try everything. Air kelapa, vitamin C, gargle. We just try everything lah.
InsyaAllah. Tapi nampaknya now COVID-19 is not that severe as compared to previous COVID-19 kan. So insyaAllah mudah-mudahan.
So because all of us already have our vaccine completed and boosted.
Your son also have already taken
yes,
2 dose.
He's 13 years old. Yes, full dose already.
Okay.
In fact, suppose nak hantar dia ke asrama ni, Prof.
Oh ya.
Dia nak register form 1. So extend lagi.
Asrama di mana?
MCKK.
Oh, MCKK. Bagus tu, sekolah cantik tu. MCKK. Alhamdulillah, sekolah Anwar Ibrahim. Okay. Alright, so let's go for our topic for today. We hope that the last topic that we have covered on multiple linear regression, where we have utilized 3 class sessions, which include the basic knowledge on the multiple linear regression, the methods in multiple linear regression, and then we also proceed on the diagnostic as well as generalization for multiple linear regression. So we hope that everyone now are more familiar and be able to understand better on application for multiple linear regression in case if you want to apply your multiple linear regression in your research. And from my observation, in most of the studies, if you are doing survey studies, if your study is a survey that will involve a questionnaire, most of the time people are using multiple linear regression in their data analysis. Even if let's say you want to join or you want to move to the structural equation modeling, which is SAM, the basic understanding of SAM is still based on multiple linear regression. So therefore, if you really have understood your multiple linear regression, if you want to move further to SAM, I won't see any problem for you to be able to grasp the procedure in structural equation modeling if you have already have the understanding on what we need to understand for multiple linear regression. So in case if you have any question on multiple linear regression, if any, otherwise we can continue with our topic today, which will be on partial correlation. And for partial correlation, we will limit our discussion in relation to what we have done for stepwise multiple linear regression. If you remember, in stepwise multiple linear regression, variables are entered in sequence, one after another, based on their significant contribution to the model. The first variable to be entered will be based on the highest zero order correlation, which is just simply the zero order correlation is just simply Pearson product moment correlation coefficient. And then the second, the third, and the fourth, and the following the other variable to be entered will be based on the highest partial correlation, not based on zero order correlation, but based on the highest partial correlation. And in addition to that, it must also be significant to be entered into the equation. So that will be what we are going to share in partial correlation. Even though previously there are other applications for partial correlation, but for now, I think we just focus our attention to the application for stepwise multiple linear regression. So that last time we have already discussed, we have shown you, we have shared the result from multiple linear regression, and we have seen the value for partial correlation, and we have seen the significance of the partial correlation, when is the case that it will be entered and when is the case that that variable will not be entered into the equation. So any question on multiple linear regression, the previous topic, if there's any?
Prof, sorry, Prof. There are some of our friends, registered friends are on the lobby waiting.
Okay. 17 plus another 5, that means 22. That means we have registered student as well as sit-in student in our class currently. But maybe the number is not that many as compared to previously because of something. Because of something. All right. So any question on multiple linear regression, Charlie? Clear? Okay, good. All right. So if that's the case, then let's go for our topic today, which would be on partial correlation. So let me share you the notes on partial correlation. Okay. Okay, first of all, we want to share on the concept of partial correlation. But what do you mean by partial correlation? What does it constitute? What does it involve in the process of the correlation between variable? So I mean, when we go for partial correlation, at least we need to have 2 independent variable and 1 DV, 2 IV and 1 DV. That means correlation between X1 on Y controlling for X2, or partial correlation between X2 on Y controlling for X1. I mean, at least we need to have 2 independent variable and 1 DV in order to see the application for partial correlation, because we want to look at the correlation between 2 variables, but at the same time, after controlling for another the correlation of another variable on the dependent variable. So here we want to share the understanding about partial correlation. Okay, let's look at these 3 variables. Exam anxiety, one of the IV. Another IV is revision time. Belum. Bila nak check up ini? Nanti masa kakak letak kat sini, nanti atuk check. Okay. All right, so we have 2 independent variables, exam anxiety and revision time, and our dependent variable is exam performance. I mean, we want to look at the influence of the 2 independent variables, the 2 factors, exam anxiety and revision time, on exam performance. Okay, so what we can see from here is, if we look at the correlation between exam anxiety and exam performance, the R is minus 0.4405, minus 0.4405, and revision time on Y is 0.3962. I mean, if we look at this correlation coefficient, which is considered as the 0 order correlation, there is higher correlation between exam anxiety on exam performance as compared to revision time on performance. I mean, exam anxiety seems to have a little bit higher correlation as compared to revision time on exam performance. And at the same time, we can also see from here that between exam anxiety and revision time, exam anxiety and revision time, there is quite a high correlation, right? Because based on Guilford, 0.7 is already considered as high correlation. I mean, there is high correlation but negative between exam anxiety and revision time. That will be the basis for our discussion on to see the context of partial correlation. So we have correlation between anxiety and performance, revision time and performance. We also have the correlation between anxiety and revision time. Okay, now, relationship between exam anxiety and exam performance. So here, if you look at the R, earlier we mentioned that the R between exam anxiety and revision and performance is minus 0.4405. That means if we were to square the value, we get the R square. I mean, in this case, if we were to square 0.4405, what we get will be 0.1940. 0.1940. I mean, what we are saying that 19.4% variance in exam performance is explained by exam anxiety. And for the revision time, the revision time. No. Here is the factors revision time. Revision time and anxiety. The R is 0.7085. I mean, if we were to square this value, I mean, what we get is 0.5020. What does it mean? I mean, we are saying that they have shared variant of 50.2% shared variant between revision time and exam anxiety. I mean, that is what we can see from the R square. The exam anxiety and exam performance, it explained 19.4%. And then between revision time and exam anxiety, the shared variant is 50.2%. 50.2%. Okay, what we can observe from here will be, this is our dependent variable, exam performance, right? And then we have exam anxiety. I mean, what we can see from here earlier, that we have 19.4% variant in performance is explained by exam anxiety. That is the contribution of exam anxiety on performance. That would be the percentage, 19.4%. But what we can see from here, for the revision time and performance, revision time performance, if we were to square this is exam anxiety, okay, 19.4%. And then for revision time is 0.157. So what we can see from here is between revision time and exam performance, 15.7%, 15.7%, which is this one here, this 15.7% of the variant in performance is explained by revision time. Earlier, we have the contribution of 19.4% of exam anxiety on the performance. But if we were to look at the revision time explain 15.7%. That will be the amount of variant explained by revision time on performance. All right. Okay, now we have one more coming. Okay, now we have exam anxiety, revision time. Earlier, we mentioned that if you were to square the R between the X1 and X2, which is anxiety and revision time, the R square is 50.2. That means 0.502. That means 50.2%. I mean, the shared common variant, between these two factors is 50.2%. 50.2%. Okay, then if we were to combine all this together, exam anxiety, exam performance, the dependent variable, exam anxiety, and then revision time, what we can see here is we have the variance explained by both revision time and anxiety on exam performance. This is the common variant explained by both the revision time and also exam anxiety, right? And then this part here will be the unique variant explained by exam anxiety. I mean, the whole part here actually is explained by exam anxiety. But since this is a revision time also explain they have shared common variant to exam anxiety. I mean, the unique contribution of exam anxiety is only this part here. It's only this part. And for the revision time, this will be the unique contribution of revision time on exam anxiety. That means what we can see from here is if we were to control, let's say between exam anxiety on performance after controlling for the revision time, that means this will be the partial correlation. That means the unique contribution of that variable on the DV after controlling for revision time. The same is also true if we were to look at the revision time on exam performance. That means the part will be here. That means this will be the portion of variance explained. But this part is shared both by the two variables, revision time as well as exam anxiety. Therefore, the unique contribution of revision time on exam performance is just this part here. This will be the partial correlation between revision time on exam performance after controlling for exam anxiety. That is basically what we need to understand about the concept of partial correlation. I mean, if we were to control another variable, because between the two variables, between the two factors, they have common or shared variant. They have shared variant between the two. Therefore, if you were to control that variable, that means the unique contribution of that the factors on the DV is the partial correlation between that IV on the DV after controlling for another variable. And that is the concept for partial correlation. Okay. For partial correlation, we have first order partial correlation, we have second order partial correlation, we have multiple partial correlation, multiple order partial correlation. But for our purpose here, since we just want to appreciate the mechanics of how it is applied in stepwise multiple correlation, stepwise multiple linear regression. So we just focus on first order partial correlation because the concept will be similar if we extend to the second order or multiple order partial correlation. So we just focus on first order partial correlation so that we can appreciate how the calculation is being done and how the mechanics involved in the partial correlation. So we just forget about the second and the third. We just focus on the first one. Okay, first order partial correlation. Application for this first order partial correlation is to determine the second variable to be included in multiple linear regression using stepwise method. I mean, if we want to know the mechanics of how the second variable is entered into the multiple linear regression model in the stepwise, then this is the application for first order partial correlation, but not the first variable to be entered, but the second variable to be entered. If you want to look at the third variable to be entered, it's not first order, but will be second order partial correlation. That means we control between x one factor on y after controlling for the two variables that are already in the model. But for the first order partial correlation, where it involves the selection of the variable to be entered in the second model, the second level, then we just want to look at the partial correlation between that variable and the dependent variable after controlling for the one variable that is already in the multiple linear regression model. Okay, so what we want to see, what we want to look here will be, we want to correlate between two variables after controlling for another variable on the dependent variable. So let's say now we can write something like this, ry2.1. What does it mean? When we say ry2.1 is correlation between y and x2 controlling for x1. That is what is meant by the symbol ry2.1. I mean, correlation between y and x2 controlling for x1. But if let's say we want to go the other way around, we can write as ry1.2. If it is ry1.2, that means r correlation between y and x1 controlling for x2. I mean, after the dot is the control variable. After the dot will be the control variable. But if this is for the first order, if it is the second order, then will be ry2.13. I mean, correlation between y and x2, controlling for x1 and x3. I mean, we control for two variables, but we are not going to discuss on the second order. We just focus on the first order partial correlation. Okay, so now, in order to work on this example, we will look at the correlation matrix, and what we can see from here is we have this variable here, x1, x2, x3, and y. And then this will be the correlation matrix that we need to be the basis for our understanding. Okay, now correlation between y and x1 controlling for x2. So we write as ry1.2. ry1.2. I mean, after the dot will be the control variable. And then we want to test the hypothesis on the significance of this the variable, the partial correlation at alpha equal 0.05. I mean, we have two things that we want to work here will be, one, we want to calculate for the partial correlation between y and x1 controlling for x2. After that, we want to test whether the partial correlation is significant or non-significant. Now, that is basically what we want to share here. So in order to calculate for the partial correlation, you need to look at the patterns of the formula. That means there is no specific formula for the calculation, but you need to appreciate the pattern. If you can appreciate the pattern, then you should be able to proceed with the calculation. Okay, let's look at the pattern for the formula. ry1.2. I mean, partial correlation between y and x1 controlling for x2. So in order to calculate for this partial, the formula will be, we just take the correlation, the partial correlation that we want to calculate, which is y and x1. So r y and x1 minus r y2. That means a correlation between y and x2 multiplied by r1 and 2. That will be the numerator for the equation will be ry1, which is the partial that we want to calculate between y and x1, and then minus ry2 here, y2, and then multiply by r12. And that will be the numerator. The denominator will be divided by square root of 1 minus whatever this this part here, r1 minus ry2 square, multiplied by 1 minus r12 square. And that will be the formula to calculate for the partial correlation. I mean, in order to do the calculation, we need to have the zero order correlation or Pearson product moment correlation between the related variable. So that means in this case, we want to know what is the correlation between y and x1, y and x2, and then between x1 and x2. I mean, that will be the correlation that we require in order to do the calculation. So between r and x1, r between y and x1 will be this one here, 0.8127. And then that means we just enter that value, 0.8127 minus ry2. y2 will be 0.5963, multiplied by r12. 12 will be here, 0.7214, right? Okay, so now, if we were to enter, then we get these three correlation coefficient that we have entered, and then divide by square root of 1 minus 0.5963 square, multiplied by 1 minus 0.7214 square. Okay, so that means once you get the pattern, then you just simply plug in the related correlation coefficient into the equation. And then now the next step will be just to solve for the equation. So what we get here will be 0.6881. I mean, partial correlation between y and x1 controlling for x2 is 0.6881. without controlling for x2, between y and x1 is 0.8127. But after we control for the variable that is already in the model, in the equation, it is reduced to 0.6881. That will be the partial correlation between y and x1 controlling for x2, right? Okay, everyone, can you see the pattern of the formula? Because there is no special formula, because it followed the variable that we want to correlate and the variable that we control for. All right, so that means the pattern will be just simply r. That means the variable that we want to correlate in this case will be y and x1. So r, y, and x1 minus r, y, and x2, multiplied by r, 1, and 2. Between x1 and x2, and then for the denominator, just put the square root, and then the first bracket will be 1 minus d square, and then the second bracket will be 1 minus d square. That will be the formula to calculate for the partial correlation. All right? Any question about that? Anybody? Is it clear?
Yes, Prof.
Okay, good. Because there is no specific formula, but we need to appreciate, we need to understand the pattern, so that if we can see the pattern, then we should be able to derive the formula from the given variable that we want to calculate for partial correlation. Okay, that will be one method that we can calculate for partial correlation, that means between r, y1, and controlling for 2. The other formula that we can use to calculate for the partial correlation will be, we can calculate, we do our calculation based on sum square regression and sum square error. I mean, if we were to run series of regression, and then we get the sum square regression and sum square error, and with that we should be able to calculate for our partial correlation. But when we do our calculation, it is not r y1.2. But when we use our when we use this sum square regression and sum square error, the value that we calculate is r square y1.2, not r y1.2, but r square y1.2. And I mean, in order to get the ry1.2, after we have solved for this equation, then we just need to get the square root of that value that will give you ry1.2, which will be similar to the calculation earlier, 0.6881. Okay, let's try. Okay, but if you want to run using this sum square regression and sum square error, first of all, we need to get the value for sum square regression and sum square error for the related model. So in this case, the formula is r square y1.2 is sum square regression, x1 controlling for x2, divided by sum square error x2. That means the variable that we control, sum square error for the variable that we control. So in this case, in order to calculate for sum square regression for x1 controlling for x2, we need to use this formula here. We get the total model, the full model, which is sum square regression for x1 and x2 in the model, minus the sum square regression where only x2 in the model. And I mean, we need to have we need to run for sum square multiple linear regression between x1 and x2 on y, and another one will be x2 on y. That means we need to run two separate multiple linear regression, as well as actually one multiple, one simple linear regression, in order to get the sum square regression, in order to be used for this calculation. So in this case, I have run the analysis. So here we have, we have 1, 2, 3, 4, 5, 6, 7. I mean, but actually we don't need the third one, because we just want to control for only one variable. For first order partial correlation, we just need to have up to here. That means in this case, between x1 and x2, that means the related model that we are interested in will be this model here, x2 and y plus x1 and x2 on y. I mean, we need to run these two models separately. When we run between x2 and y, the result for the sum square regression is 421.335, and standard error, sum square error, not standard, sum square error is for x2 will be 763.632. But when we include both x1 and x2 on y in the multiple linear regression, the sum square regression is 782.901. But we are not interested in sum square error for x1 and x2. So we need to have this value here. This, and this. Okay, let me repeat. In order to get that sum square regression and sum square error, we need to run two separate regression analysis. One is simple linear regression between y and x2 in order to get the sum square error. This one, sum square error, as well as sum square regression for x2. I mean, we need to have this and this. And then we also need to have sum square regression for x1 and x2 on y, where the sum square regression is 782.901. So that means if we were to plug in the value into the equation, so what we get is 782.90092 if we were to expand to 5 decimal places, which is this one here, minus sum square regression for x2. So sum square regression for x2 is 421.335. I mean, at 5 decimal places is 421.33495. And then divide by sum square error for x2. Sum square error for x2 is 763.6317. That will be the value that we need to enter into to be entered into the equation. And then when we solve for this, what we get is 0.4735. It's not the same as what we did the calculation earlier. But remember, the one that we calculate is r square. The one that we want is actually just r, is that right? So in order to get the r, we just get the square root of the r square y1.2, where if we were to get the square root of 0.4735, the value that we get is 0.6881. I mean, regardless whether you are using the first formula or the second formula, the first formula using zero order correlation, the second formula using sum square regression as well as sum square error from result for regression analysis. Okay, so now we have two formula that we can do that we can use in order to calculate for partial correlation using the first formula, which is based on zero order correlation, or the second formula using sum square regression and sum square error. Okay, now based on this, what we can see is there is a positive and moderate relationship between y and x1 controlling for x2. I mean, we can use the same principle. I mean, we can use the decision criteria given by Guilford. 0.6881, it is in between 0.4 to 0.7, so it's still considered as moderate. So we can say there is a moderate and positive relationship between y and x1 after controlling for x2. That will be the interpretation for the correlation, the partial correlation. Okay, now, whether this variable, if let's say this variable this partial happen to be the highest, it will not be included directly into the regression model, but we need to check whether the partial correlation is significant or otherwise. If it is significant and it is the highest partial, yes, that variable will be entered into the equation. But if it is highest but it's non-significant, it will not be entered into the next level in the next model in the multiple linear regression. So in order to test for the significance of that partial, we use this, we are using the 5-step procedure also. Step number 1, we state the HOHA, where HO is rho y1.2 equals 0. That means partial correlation between y and x1 controlling for x2 is equal to 0. Against the alternative hypothesis, row y1.2 not equal to 0. That means it is not equal. That means there is significant relationship between y and x1 controlling for x2. Okay. Step number 2, we need to calculate our test statistic. In order to calculate our test statistic, the statistic that we will be using will be F ratio, where the F ratio, the formula is sum square regression for x1 controlling for x2 divided by 1, that 1 because we are controlling for only one variable, and then divide by sum square error between x1 and x2 divided by n minus p minus 1, n minus p minus 1. So that means in this case we don't divide by sum square error for x2, but we divide by sum square error for x1 and x2. That means we use the sum square error for the full model. When we say the full model, that means it includes both variables, x1 and x2. Okay, so now if we were to look back at the value, okay, sum square regression for x1 and x2, as what we did earlier, is 782.901, and then sum square regression for x2 is 421.335, and then the whole thing that they just divide by 1, and then divide by sum square error for x1 and x2. Sum square error for x1 and x2 is this one here, 402.066 divided by n minus p minus 1. That means this will be the degree of freedom for the denominator. Degree of freedom for numerator is 1. Degree of freedom for denominator would be n minus p minus 1. So in this case, for this data set, we have n equal 30. So sum square regression for x1 and x2 minus sum square regression for x2. So we get 782.901 minus 421.335 divided by 1. And then sum square error for x1 and x2 is 402.06575 divided by n, which is 30. And then p, we have two variables, x1 and x2. That means we have minus 2 and then minus 1. That means 30 minus 2 minus 1 will be 27. Right? So that means if we were to solve for this, what we get is 24.2803. That is the calculated statistic. F equal 24.2803. Okay, now, in order to determine whether it is significant or not significant, the next step will be we need to determine the critical value. The critical value for F, we need to have 2 degrees of freedom. The 2 degrees of freedom come from 1 and 27. 1 and 27. So at 1 and 27 at 0.05, the critical value is 4.23. 4.23. All right, so that will be our critical value. And then now the next step is, in order to make our decision, we just need to compare our F calculated against our F critical. So F calculated was 24.2803 and F critical 4.21. Therefore, F calculated is higher than F critical. When it is higher, what should be our decision? Reject or fail to reject?
Reject, teacher.
Reject the null hypothesis. When we reject the null hypothesis, what we can conclude is there is significant partial correlation between x1 and y controlling for x2 at 0.05 level of significance. Right? That will be, I mean, that value, the value for the partial correlation, which is 0.6881, is found to be significant at 0.05. Therefore, if this partial happen to be the highest among the two, if these are the two potential variables to be entered, but shouldn't be, is it right? Because this is only 2 variables, but we should have 3 variables, right? Should have 3 variables. Okay, now, so if this happened to be the highest partial and it is found to be significant, then this variable will be entered next into the equation. Right? Next in the equation will be entered. So which variable will be entered? X1 or X2? Malay?
X1.
Okay, we have calculated for the partial correlation between X1 and Y controlling for X2, and then we found the value to be 0.6881. And when we interpret the strength of relationship, we can say that there is a positive and high There's a positive and moderate relationship between x1 and y controlling for x2. And then when we test for the significance of this variable, I mean, it is found to be significant. If this happens to be the highest partial, then the variable will be entered into the equation, right? So which variable will be entered, x1 or x2?
X1.
I mean, the variable to be entered is x1. I mean, here, as if x2 is already in the model, x2 is already in the model, I mean, is entered in first in the first level or the first model. Then the second model, x1 will be entered into the equation. I mean, we have x2, and then after x2, x1 will be entered. I mean, that is what we would expect if x2 were to be the first variable to be entered into the equation. Okay, another example here will be correlation between y and x3 controlling for x1. So that means the symbol, when we write the symbol, we just write as r y3.1. What does it mean? R, I mean correlation between x3 and y controlling for x1. And then we also are interested to test whether the partial is significant or non-significant. So what we need to do next will be, first of all, calculate the partial correlation. But before we can calculate the partial correlation, we need to come up with the formula. Okay. If we don't look at the formula in our notes, okay, if you want to calculate r y3.1, what should be the formula? The formula will be r. If you don't look at the notes, we want to appreciate the pattern. So it will be r y3.1 equal r y.
Right.
Y3 minus r y1 multiplied by r
Y3.
Y3, not y, but r13. I mean, the sequence will be r y3 minus r y1 multiplied by r13. That will be the numerator. For the denominator will be square root of the first bracket 1 minus r y1 square, and then up in the second bracket will be 1 minus r13 square, 1 minus r13 square. That will be the formula. I mean, if you were to look at the formula, that is the formula. ry3 minus ry1, not this one is up in by right, should just one without that, not double one, but just one. ry1 multiplied by r13 divided by square root of 1 minus ry1 square, and then multiply 1 minus r13 square. That will be the formula. So once we derive the formula and then we observe the zero order correlation, we can just simply plug in the value. ry3 is 0.6659, right, minus ry1. ry1 is 8127, minus 0.8127, multiplied by 13. 13 will be here 0.5441, and then divide by square root of 1 minus whatever this value, but in this case 0.8127 square. The second bracket will be 1 minus 0.5441 square. Okay, and if you were to solve for this, this by right should be only one full stop. I mean, one decimal point. So 0.2237 divided by square root of 0.3395 multiplied by 0.7040, which is equivalent to 0.2237 divided by 0.4889, which is equivalent to 0.4576. And I mean, the partial correlation between x3 and y controlling for x1 is 0.576. If we don't control the correlation, we didn't go for the partial correlation. RY3 was 0.6659, but after controlling for X1, it is reduced to 0.4576. That means some of the contribution, the variant is explained by X1. So that's why it is reduced to 0.4576. That is the first formula. The second formula will be, here I didn't share the second formula. I didn't share. But if you want to calculate the second formula, what should be the formula? The formula will be R
square
y3.1 square equal sum square regression for X3
X2
controlling for X1 divided by
sum square error
sum square error for X1. That means the variable that we control, X1. That will be, if you want to use the second formula for the calculation using sum square regression and sum square error. You can try based on the earlier summary statistic that we have shared earlier here. Based on this summary statistic, then you can do the calculation and compare the result. By right, the result should be as perfect as what we have done for the first equation. If you were to use the second equation, it will be also the same thing. Okay. Okay. Another example here will be RY2.1. The first one was RY1.2. The second example was RY3.1. Here will be RY2.1. Okay. So now, if you were to calculate for this, then the formula will be before that. Maybe good idea for us to derive the formula. We are calculating for RY2.1. Okay, the formula will be RY2.1 equal R
Y2
minus
RY1
Y1 multiplied by
R12.
R12. Whether you write 1, 2 or 2, 1 will be actually the same thing. So that will be the numerator. The denominator will be divided by square root. The first bracket will be 1 minus RY1 square. Right?
Y1 square.
Okay, and then the second bracket will be 1 minus RY2 square.
Yeah.
R12 square. Right? And that will be if we were to do the calculation, so that will be the formula. So we can just plug in. When we plug in the value, what we get from here will be 0.5963, which is RY2, minus RY1 0.8127, and R12 is 0.7214. And when we plug in all the value up in accordingly, and what we get here will be 0.0248. That means after controlling for X1, you see, the contribution, the correlation between R and Y and X2 is reduced very much, right? From 0.5963 now become 0.0248. I mean, much of the variant is already explained by X1. I mean, the additional amount of variant explained by X2 is minimal because most of the variant has been explained by X1. Right, by X1. Okay, so that means here we have the second example using the sum square regression and sum square error for RY2.1 square, which is equivalent to sum square regression of X2 controlling for X1. In order to calculate for this numerator, what we need to do, we get the full model, which is correlation, the sum square regression X1 and X2 on Y, minus sum square regression for X1, the variable that we want to control, divided by sum square error for X1, the variable that we control. So that means if we were to plug in the value, what we get here, sum square regression for X1 and X2 is 782.901, here, 782.901, minus 782.652, which is a sum square regression for X1 here, 782.652, and then divide by standard sum square error for X1, which is 402.315. So if you were to solve for this, what we get is 0.000619, 0.000619. 619. That is the R square for Y2 controlling for 1. Y2 controlling for 1. So in order to get the partial correlation, just R, then we just get the square root of that value, which is equivalent to 0.0249. This is because of the round up error. Because if we were to use more decimal places, then the value should be as close as possible. So in this case, 0.0249. That means if you were to test for the significant, what would be the expected result? Should it be significant or non-significant with this partial correlation?
Non-significant.
Why? Because it is too small, is it right? Negligible. 0.0. This is not enough. 0.0249 or 0.0248 is considered to be very low. Therefore, if you were to test for the significant, most probably it won't be significant. Okay, let's proceed with the test for the significance. Okay, HO, step number 1, rho Y2.1 equals 0 against the alternative hypothesis, rho Y2.1 not equal to 0. That will be step number 1. Step number 2, we want to calculate the test statistics. So we are using the F ratio. So F equal sum square regression for X2 controlling for X1, and then divide by 1 because we are controlling only one variable. And then divide by sum square error for X1 and X2, that means the full model, X1 and X2 together, divide by N minus P minus 1. So which is equivalent to, in this case, sum square regression, the same thing that we have done earlier. X2 and X1 is 782.901, and sum square regression for X1 is 782.652. And then divide by 1, and then divide by 402.06575, divide by N, which is 30, minus 2, minus 1. 2 is the our variable. We have only two variables in the model, X1 and X2. So what we get here will be, if we were to solve for this, the F is 0.0167. I mean, as expected, when the when the R is low, when we calculate for the test statistic, in this case, the F ratio should also be low. When the F ratio is low, then if we were to compare with the critical value, the tendency will be the calculated statistic F will be smaller than the critical value, therefore fail to reject the null hypothesis. So that means here that will be the test statistic value. Okay, next step, step number 3, critical value, the same thing, F1 and 27 at 0.05 is 4.23. The next step is we want to make decision. In order to make decision, we just compare the F calculated against F critical. So F calculated is 0.0167, which happened to be smaller than F critical 4.21. Therefore, in this case, 4.21 or 4.23, because let's check our table. Let's check our table. F1 and 27. Okay, at 0.05, 1 and 27. Okay, we don't have a 27 there, right? But what we have are 26 and 28. Okay, so since we don't have exactly 27, so it happened to be equidistant. 27 is equidistant to 26 as well as to 28. So in this case, should we report as 4.23 or 4.20?
23.
Or 4.23, as what we did earlier for our this normal distribution. If it is equidistant, we go for the lower. So the lower is 4.23. That means it's not 4.21, but it should be 4.23. Okay, so since this is smaller, therefore, fail to reject the null hypothesis. When we fail to reject the null hypothesis, the conclusion is the partial correlation between Y and X2, Y and X3 controlling for X1 is non-significant. It's non-significant, right? Because the F calculated is smaller than F critical, and the amount of variance explained is considered to be very low. That means if we were to square the R that we get earlier, the value is very small. That's why the contribution is non-significant. And that is what to expect for when we test for the significance of the hypothesis for this correlation. Okay, let's try this. Everyone, don't look at your notes for a moment. Try to calculate for R y2.3. R y2.3. First of all, try to come out with the equation, the formula to calculate for R y2.3. And then after that, yeah.
Yeah, it's okay. I just want to explain the equation.
Okay, all right. So just try to work up in it on your sheet, the calculation for R y2.3, partial correlation between y and x2 controlling for x3. Okay, the formula is ry2.3 equal ry2 minus ry3 multiplied by r23 divided by square root of 1 minus ry3 square multiplied by second bracket 1 minus r23 square. Is it right? Okay, now you just plug in the value and then proceed with the calculation. So what we get here, that means that will be our partial, the zero order correlation. Then when we enter the respective correlation into the equation, what we get is, in this case, 0.4183. 0.4183. I mean, as expected, because we control for another variable. Initially, correlation between y and x2 is 0.5963. But after controlling for x3, it is reduced to 0.4183. That is what to be expected, because some of the variance is explained by the control variable. So what can we say? What can we interpret based on that partial correlation? There is a positive and
moderate.
yes, still moderate. But earlier was 0.6881 is near to 0.7, right? But here is just enough to say moderate, because 0.4183. That means there is a positive and moderate correlation, partial correlation between y and x2 after controlling for x3. Okay, but if you were to use the second formula will be r square for y2.3, which is equivalent to sum square regression for x2 controlling for x3 divided by sum square error for x3. So which is equivalent to sum square regression for the full model. When we see the full model, that means it includes x2 and x3 together in the model, minus just y and x3, which is sum square regression for x3, divided by sum square error for x3. I mean, if we were to enter the value accordingly into the formula, what we get is, in this case, r square y2.3 is 0.1750. But if we were to square root that value, we should be able to get the r y2.3, which is equivalent to 0.4183. And I mean, still, the result will be the same, regardless whether we are using the first formula, using the zero order correlation, or using the sum square and sum square regression and sum square error. We still get the same result for the partial correlation. Okay, having that, in this case, considered to be lower, just moderate relationship. So we want to test whether the partial correlation is significant or non-significant. So in order to test, we proceed to the 5-step procedure. Step number 1, we state the hypothesis, HO, rho y2.3 equals 0 against the alternative hypothesis, rho y2.3 not equal to 0. Second step, we calculate the test statistic. where in order to calculate the test statistic, we just use the F ratio. So F equal sum square regression for x2 controlling for x3 divided by 1, and then divide by sum square error for the full model divided by n minus p minus 1. So which is equivalent to, in this case, if we were to plug in the value, F equal 5.7260. 5.7260. Okay, that means we cannot make our decision yet, but in order to decide whether the relationship is significant or non-significant, we need to get to step number 3, where we need to determine critical value. So critical value will be, in this case, 1 and 27, the same, which is 4.23. That will be our F critical. And then step number 4, we just compare between the two. In this case, our F calculated happened to be bigger than F critical, therefore reject HO. Is that right? Based on our decision criteria, reject HO. When we reject HO, what we can conclude is there is significant partial correlation between X2 and Y after controlling for X3. That will be what we can deduce from our example that we have done based on the one that we can see on the screen. Okay, so it is very straightforward, right? It's very straightforward. Then we can see the mechanics, how the values are being derived. Otherwise, when we go for the species output, we can see the result, partial correlation. But we don't have any idea how the value are being derived. But at least by now, we should be able to appreciate how the values are being calculated and how we determine whether that partial correlation is significant or non-significant. Okay, so any question about that? Okay, now we go for the partial correlation based on the step based on multiple regression result. Maybe this is the same as this. Okay. But before we proceed on with this stepwise multiple regression, let's go back here. If you have any question on how to write the symbol, how to derive this formula, how to get the zero order correlation matrix, and how to get the result for sum square regression as well as sum square error from the respective regression model. So any question on that? If there's any, let's go for the plenary session. After all, our number now is smaller, so that means easier to manage. Okay, any question now? Oh, somebody has written chat. I'm driving on my way back. Oh, somebody is following the class while driving back to home. Okay, so drive safely. Otherwise, we may incur something. Okay, Jury, any question? Clear?
Cuma saya pelik, Prof. Yang sebenarnya formula yang dapat SSR tu dengan SSE tu memang dah sedia ada lah.
Bukan, maknanya we have to derive from the analysis. We need to generate the result.
Dululah.
Jadi macam tadi kan, when we say RY1 sum square regression X1 controlling for X2, that means what we need to do will be we need to run two regression model. The first regression model is X1 and X2 on Y. The second regression model is X2 on Y. That means we need to run separate regression analysis in order to derive the sum square regression as well as sum square error.
Okay.
But if you were to use the first formula, you don't have to worry. But in order to test for the hypothesis, you still need to use the sum square regression and sum square error. Even though if, let's say, you use the first formula where we are using the zero order correlation to calculate for your partial, but in order to test for the significance of that variable of that partial correlation, we still need to go to sum square regression and sum square error. I mean, This we need to run separately from the data.
Okay.
Prof,
Yeah.
Prof, in your
Yeah.
examination, you are going to provide us with all the values, right? We don't have to generate
Oh, yes.
the values.
No. All the values will be given, but you just need to extract the relevant values from the given summary. Not to enter everything. You have to be selected. I mean, we know if let's say we want to get some square regression for x2 and x3, x2 controlling for x3, I mean, it must be some square regression for x2, x3, and then minus some square regression for x3. Gitu. Jadi maknanya we need to know which of the summary result that we need to extract into the calculation.
Prof,
Juriah macam
Iman here.
risau ya, nothing to worry. We just need to observe, and then after this we will share how to derive, if there's any need, how to derive the respective sum square regression and sum square error. Okay, Imah, your question?
Here, Prof. I would like to ask, because I'm in the middle of choosing the right construct or model to be combined to create novelty, right? So can we just find from the literature that this construct has a strong relationship in the partial square value whatsoever as a proof that we take that construct to be combined in our model?
Okay.
Can.
In the first place, Ima, before you derive your research conceptual framework, before we derive your research conceptual framework, we need to look for specific theory that will be the basis for you to establish your research framework. I mean, we don't just simply plug in any variable from anywhere and then, okay, these are my set of IVs, this is my DV. We cannot just simply establish as such, but the establishment of your research conceptual framework, which include your IV and DV, must be based on a strong theoretical opinion, strong theory. I mean, you select a specific theory to be the basis for your framework. But for PhD, it is not just enough for you to copy what the theory have to say. Maybe we want to add something to the existing theory. So that's why that will be your contribution to the body of knowledge. So in order to add something, maybe we look at other theory or other model in the literature where we should be able to identify other variable that can be the DV, that can be the IV, or another variable that can be incorporated as mediating or moderating variable. I mean, in that case, you have something extra than what the original theory have to say. I mean, the basis for you to establish your framework must be based on strong theory, right? I mean, all the variables selected are based on what you have observed through literature, especially through the specific theory that you have gone through, that they have selected, that are relevant to be incorporated into your study. But here we are looking at when we run for the multiple linear regression using stepwise method. Okay, the first variable to be entered, we know by now, it is based on the highest zero order correlation. That will be the first variable to be entered into the multiple linear regression using stepwise method. But now, in order to appreciate how the second variable is entered into the equation, in order to, we have already discussed that when we discuss about multiple linear regression, but here we want to see the mechanic on how we derive the partial correlation. And then we also, because in order for that variable to be entered in the second model, it must be the highest, and at the same time, it must also be significant. So we also share how to test for the significance of that partial correlation. That is basically what we are doing here, Ima. Ima?
Yes, Prof, I understood that.
Yeah, that means we are going to select the variable, because the variable are already selected when you establish your framework. But here we want to appreciate how the mechanic is being done in order to decide on which variable to be entered in the second model. after the first variable has already incorporated into the simple. Initially will be simple linear regression between x1 between one IV and DV. But the second variable to be entered will be based not on the highest zero order, but will be based on the partial correlation. Partial correlation. Okay, any other question? Saya tengok juri dia masih macam khawatir lagi. Don't worry, our exam is not this week, next week. By the time you should be able to digest the mechanics on the calculation and the step by step, everything should be in place, inshallah. After, especially if you have done your assignment. If you have done your assignment, then you are more ready for the exam. Okay, Faiza? Fikirkan anak ke fikirkan the topic? Okay, others, any question? Nada. Okay, if there is no question, let's look at the application of this in multiple linear regression. Okay, let me minimize this. Oh. Okay, so we have here three variables, x1, x2, and x3, and then we have the dependent variable y. Okay, now in the first model for this in the stepwise multiple linear regression, as we have already known, the first variable to be entered into the equation will be based on the highest partial, based on the highest zero order correlations. Yeah, right? Okay, that means if we were to look at the the first row here. I mean, these are correlation between x1 and y, x2 and y, and x3 on y. So that means based on that, the correlation matrix result, then which variable should be entered first into the equation? Into the x1. Why x1?
X1.
Now, why x1?
The highest
because
value.
it is the highest zero order correlation, is it right? Because the rest are 0.596 and 0.666. Therefore, the highest is 0.813. Therefore, the first variable to be entered into the equation will be x1. When we enter x1 into the equation, that means if we were to square 0.813, what we get is 0.661. Is it right? So what can we say when we square the r? The r square is 0.661. What does it mean? In this case, what we are saying is x1 explain 66.1% variant in y. And I mean, out of the total variant, 66.1% is explained by x1. Okay, now that is the first model. That means the first variable to be entered into the multiple linear regression using stepwise method. So when the first variable is entered, how many variables are outside of the model? How many remaining variable? How many remaining factors in the outside of the model?
Two factors.
And the two are x2 and x3.
X2
right?
and X3.
And I mean,
yes.
In the second model, in the second level in the multiple linear regression in the stepwise method, the potential variable to be entered into the model will be either x2 or x3. In order to decide whether x2 or x3 to be entered into the equation, what we need to do will be, we need to calculate two partial correlations, right? What are the two partial correlations that we need to calculate?
RY 2.1 and RY 3.1.
Okay, the two correlation will be RY 2.1 and RY 3.1. 3.1, yes, because x1 is already in the model. I mean, that variable we need to control because that variable is already in the model. So the two partial will be RY2.1 and RY3.1. So in this case, what we need to do will be, we need to proceed on the calculation for the two partial. So that means we have already shown the example earlier. So the two partial correlation that we need to calculate will be RY2.1, which is equivalent to RY2 minus RY1 multiplied by R12 divided by square root of 1 minus RY1 square, and then minus and then multiply by 1 minus RY2 square. And I mean, if we were to enter the value accordingly, what we get for RY2.1 is 0.0248. That means only we should consider to be very low, 0.0248. But if you were to calculate another partial, that partial will be RY3.1, which is equivalent to RY3 minus RY1 multiplied by R13 divided by square root of 1 minus RY1 square multiplied by 1 minus RY12 square. I mean, if we were to enter the value accordingly, the partial correlation that we get in this case will be 0.458. I mean, now we have the two partial correlation, the two values for the two partial. So between the two, which one is the highest? Which one is higher? The highest is 0.458, right? The partial correlation that is highest in this case is 0.458. So that relate to RY3.1. I mean, a partial correlation between Y and X3 controlling for X1. So now, the one that we need to test for the significance will be, is it the first or the second?
Second.
The second, because that is the higher partial correlation. I mean, we just need to test for the second partial correlation, which is between R between Y and X3 controlling for X1. So in this case, we just need to test for the second partial. So in order to test for this, we go for the 5-step procedure. So step number 1, HO rho Y3.1 equals 0 against the alternative hypothesis rho Y3.1 not equal to 0. Step number 1. Step number 2, we calculate the test statistic. So our test statistic in this case will be our F ratio. So the F ratio will be SSR, sum square regression of X3 controlling for X1 divided by 1, and then divide by sum square error for X1 and X3. I mean the full model. And then divide by n minus p minus 1. So in this case, if we were to enter the value accordingly, sum square regression for X1 and X3, is 866.882 minus sum square regression for X1, which is 782.652, and then divide by 1, and then divide by sum square error for the full model X1 and X3, 318.084, and then divide by 30 minus 2 minus 1. So if we were to plug in if we were to solve that equation, what we get is 7.150, 7.150, and that will be our F calculator. But in order to decide whether it is significant or non-significant, we need to proceed to step number 3, where we determine the critical value, F at 1 and 27, which is 4.23. And then if we were to compare, 7.150 happened to be bigger than 4.23, not 4.21, right? Bigger, therefore, reject the null hypothesis. When we reject the null hypothesis, then the conclusion will be the partial correlation between Y and X3 controlling for X1 is found to be significantly is found to be significant. That means the correlation is significant. Therefore, would you expect this variable to be entered into the next model in the second opinion level in multiple linear regression?
X3.
Yes, because why? Yes, because the partial correlation, it is highest, and in addition to that, it is also significant. But if it is highest but non-significant, it will be not entered into the equation. Okay, that means now in your regression model, you have X1 and X3, and then we have one more variable that is outside, that is the remaining variable. And then if we were to decide on whether that third variable to be entered into the equation, we need to calculate the second order partial correlation. I mean, correlation between Y and X2 controlling for 1 and 3. Controlling for 1 and 3. But we don't have to look at that one because we just want to appreciate the mechanics, how to calculate for the partial and how to test for the significance of the partial correlation. But for the second order or the multiple order partial correlation, the concept is basically pretty much the same, but the calculation, of course, the formula will be a little bit complex because it involves two variables that we control, right? I mean, in order to calculate for the second order partial correlation, then we need to use this first order partial correlation in the calculation. But we don't have to work on that one. Okay, can you see that? Okay, now having that, so now if we were to run, okay, if we want to, okay, here we have the first variable x1, the second variable x3. If you want to know how much additional variable, how much additional variant is explained by the second variable, earlier, when we look at the result earlier, the first variable, when we enter x1, when we enter x1, 66.1% variant is explained by x1, is that right? So now if you want to know how much additional variant is explained by the second variable, which is x3 into the model, then we can proceed to this calculation here. Okay, so change in R square equal R square y1.3, I mean this partial correlation between y and x3 controlling for x1, multiply by 1 minus R square. I mean the R square earlier was 0.661, right? So in this case, R square y3.1 is 0.458 square, which is equivalent to 0.2098. And then 1 minus 0.661 is 0.339. So when we multiply these two coefficients, what we get is 0.0711. So that means what we are saying is, in addition to 66.1% variant that is explained by x1, x3 add another 7.11%. 7.11%. That is the formula to calculate for the additional R square that is attributed by the second variable into the regression model. Right? So the formula is change in R square change equal R square y3.1 multiplied by 1 minus R squared. I mean the R square is the earlier based on the first opinion model, 1 minus R square. And if we were to solve for that, in this case, what we get is 0.0711. I mean, this second variable, which is x3, explain another 7.11% variant in the y, whatever the y. Okay, that will be what to expect for. Okay, this one, additional information. I mean, if you want to know more about this partial, then you can proceed to this one here. We have additional, but I just extract only the crucial information that we need to understand for this subject, so that we can appreciate the application for stepwise multiple linear regression, where we incorporate the partial correlation into the procedure to decide on which variable to be included in the second model. Of course, if you want to go to the third model, you have to go to the second order partial correlation. Okay, so let's try to share how to run this in SPSS. Okay, let me look at the data set first. This is our, let me check. Document. Data set. Class data. Let me check. Okay, this is the data set. Okay, let me share you the data set. The name of the data set is 6953 partial correlation 2.sav. Okay, let me share you the data set. Okay, document. to courses. And then 6953 data set. And okay, I have already uploaded the data set, so please download the data set so that we can run together how to get the partial correlation, also how to generate the zero order correlation, as well as how to get the sum square regression as well as sum square error for the respective model. Okay, once you download the data set, open the data set in SPSS. Let me show you. Okay, this is our data set. We have 30 cases, X1, X2, X3, and the dependent variable is Y. Everyone, are we done? Have you downloaded the data set and have you opened the data set?
Yes, Prof.
Okay, good.
Yes,
What about the rest? Done? Since no response, I mean, I take for granted. I mean, it's okay. So now,
Baru nak buka tau.
apa nak buka? Okay, bagi cakap bagus. Bagus saya dengar. Okay, buka.
Sikit.
Jangan buka apa ini kuis raya pula. Buka apa ini data. Saya balik kampung itu apa ini bawa kuis spade. Tahu kuis spade? Kuis spade.
Tahu, Prof nak bagi ke?
Tak adalah, kita pun beli. Tapi kalau datang bolehlah makan kat rumah. Nak bagi tu tak adalah, ada sikit je. Beli tu pun itu apa ini beli atas orang lain sebab apa ini order telah ditutup. Okay, now Julia, then have you opened the data? Dah, okay. Okay, now in order to run for this partial correlation, that means the one that we ran just now was RY3.1. RY3.1. In order to run for RY3.1, what we need to do will be, okay, in the first place, let's look at the result just now. What do you get? The partial was 0.0248, 0.458. Okay, let's run through this SPSS, whether we get the same result, 0.548. Click on analyze, click on correlate, click on partial. When you click on partial, then enter the variable that we want to calculate for the partial. In this case will be Y and X3. I mean, the variable that we want to correlate is Y and X3. Controlling for, enter X1 into here. That is how we enter the variable into the dialog box. In this case will be Y and X3 controlling for X1. Okay, once done, simply click on OK. When you click OK, and if you were to look at the result, you see the result given here is the R 0.458, and the significant value. Okay, let me show you the SPSS viewer. If you look at the SPSS viewer, this is the result. This is the partial correlation, right? So the value that we get is 0.458. Right? Similar to with our manual calculation just now, what we can say is there is a positive and moderate relationship between Y and X3 controlling for X1. And if you were to test for the significance at two-tail, the value, the p-value is 0.013. So since 0.013 is smaller than 0.05, therefore reject the null hypothesis. When we reject the null hypothesis, that means we are saying that yes, partial correlation between Y and X3 controlling for X1 is significant. I mean, there is significant partial correlation between Y and X3 controlling for X1 at 0.05 level of significance. That is how, if you want to run that in SPSS. And this the earlier we run for 2 just now, is it right? RY1, RY2.1 and RY3.1. Okay, if you were to run RY2.1 in our calculation earlier, RY2.1 is 0.0248, 0.0248. Okay, let's check. If we were to run using SPSS, do we get that result? Okay, just run here. Click on analyze, click on correlate, and click on partial. So we just remove X3, just enter X2. I mean, this case will be partial correlation between Y and X2 controlling for X1. What we get from our calculation was 0.0248. Okay, if we were to click on OK, and then the result is 0.025 because it rounds up to 3 decimal places. Right? I mean, similar with our calculation. And if we were to test for the significance of this partial correlation between Y and X2 controlling for X1, the p-value or the significant value is 0.898, which is bigger than 0.05 and which is non-significant. Right? Non-significant. Okay. Okay, to fulfill the curiosity for our member here, Julia, how to get the sum square regression and sum square error. Okay, now, in order to test, okay, between X3, Y X3.1, that means if you want to test for the significance, the two regression model that we need to run will be, one will be Y and X1, right? Y and X1. The other one will be Y, and the full model will be X1 and X3 on Y. I mean, when we need to run two separate regression. Okay, how to run? Okay, what you need to do will be just click on analyze. Okay, the first one we run the full model. Okay, regression, linear, and then enter dependent variable Y. Okay, for the full model will be X1 and X3. So enter these two variables into the independent box. So in this case, we run multiple linear regression between X1 and X3 on Y. And then if we were to click on OK, then we should be able to get from the ANOVA table sum square regression 866.882, and then sum square error is 318.084. Okay, we need one more, right? Because we need to in order to get sum square regression for X3 control for X1, that means we need to have sum square regression for this model, I mean the full model, minus sum square regression for X1. In order to get sum square regression for X1, we need to run another regression. So in this time will be a regression, linear, and then we just remove X3. I mean, we just run between X1 and Y. I mean, between one IV and one DV. Okay, when we were to click OK, then we should be able to get the sum square regression here. Sum square regression for X1 is 782.652. I mean, that is how we derive the sum square regression and sum square error for the respective model. Which model that we need to run depend on what is the partial that we run for. Right? I mean, based on the partial, and once we derive the equation, then we know which of these regression model that we need to run. We don't have to run all the combination, but we just need to run the respective model so that we just get the result for sum square regression as well as sum square error in order for us to plug into the equation to get the F ratio in order to test for the significance of the partial correlation. Right? Okay, Charlie, any question, Charlie?
So, Prof, so yeah. if we run partial correlation, if it's not significant, then there's no point running in the multiple regression because they will exclude it anyway, right?
Okay, in the first place, actually, we don't have to run partial. We run partial because we just want to ascertain, to go in depth on the mechanics of how is error derived. But we just need to run our multiple linear regression. But in case if you want to explain why these variables are not entered into the equation, maybe initially when we run correlation between x1 on y, x2 on y, x3 on y, all are found to be high, what we observed earlier. But how come after we enter x1, after the software enter x1 and enter x3, it just stopped? That means if you want to explain, then we can see the detail when we go for the partial correlation. But we don't have to run the partial initially, but the partial can explain the mechanics, how variables are entered and how variables are not entered into the multiple linear regression model.
Yeah,
okay, so any question?
Yeah, so we can use this for like moderating effect, so we can see how much the correlation between the IV after we run the.
Okay, but now, Charlie, we are in year 2022. We are in year 2022. I mean, when you run for your analysis, even though it may answer your purpose, but since we have a more advanced procedure to test for the moderating or mediating effect of the variable, then we need to use the more recent method. So maybe if you were to run the old method, example, previously, in order to test for the mediation effect of in SAM, structural equation modeling, people utilize MMA, which is multi-model analysis, in order to test for the mediation effect. But now we have a more recent method where most people are using the bootstrap procedure in order to test for mediation effect. Therefore, if we were to use the MMA, maybe the examiner will ask inquire, is there any more recent procedure in order to test for mediation effect? And then if you can't answer, then you're in trouble. But if you can answer, then the question, the next question asks, why don't you use the more recent method in order to test for the mediation effect? Then the same it will be applied here. To a certain extent, yes, we can use this in order to test for that. But we have a more recent, recent method. Therefore, it is advisable to use the more recent method. So that's why for PhD, if you are doing your research, not for experimental study, most probably you may be able to apply structural equation modeling, not just simply multiple linear regression, but instead we go for SAM, structural equation modeling. So that's why we need to go one step further. After all, we are in year 2022. In no time, we will be in 2023. Depending on when you will graduate, maybe you will graduate in 2024. Therefore, a high reason for you to explore new method so that you can apply the new method into your data analysis. Okay. Are others any question?
Prof.
Yeah.
Prof, can you please repeat the information of our first examination, because some of us did not get to hear it just now.
Okay. Okay, I will share that one afterward. But now we just focus on this one. If anybody have any question for clarification on our topic for partial correlation, if there's any. Otherwise, after that, inshallah, I will share what to expect for your midterm exam, especially for those, not especially, only for those who are registered. I mean, I expect only 17 students will sit for the exam. The rest just attend. I mean, for next week, sit in, don't have to attend, because next week will be exam midterm. Okay. Any question for partial correlation? Additional question, if there's any? But it's
Prof.
right?
Prof.
Yeah.
Prof. So can you show us how to get the zero order correlation?
Oh, zero order correlation. Okay, from this analysis. Okay. In order to get the zero order correlation, it's just easy. You can just go for correlate, bivariate, and then In order to make life easy, I would prefer to enter the dependent variable first, because when we look at the result afterward, we can focus our attention to the first column. That means you get x1 on y, x2 on y, x3 on y. If you have more, x4 on y, x5 and on y, and so on and so forth. And then we just enter the first variable, the dependent variable first, and then followed by the independent variable. And then simply click on OK. That's it. And then when you click on OK, that means you get the result here. That means this will be the y, the dependent variable. This is correlation between x1 on y, x2 on y, x3 on y. This is your zero order correlation matrix. Right?
Okay.
Okay, good. Okay, let's see now. Maybe. Okay, all right. Okay, now if there is no question on partial correlation, okay, we want to share or we want to clarify further on our midterm exam. Okay, our midterm exam will be inshallah next week, class time 2 to 5, and the topic to be included will be from the beginning until our topic today, which is partial correlation. And our midterm exam, for those who have already taken my 5950, the nature will be pretty much the same. I mean, it comprises of two sections, section A and section B. Section A will be on knowledge, and it will be about 20% of the total. And the nature of the question will be either multiple choice or maybe true and false, or maybe short answer, but most probably will be either multiple choice or true and false. I mean, only two option for a question in section A, which will be about 20% of the total. The second part, section B, will be application. I mean, when we say application, that will include the manual calculation plus interpretation for SPSS output. Calculation plus interpretation for SPSS output. So you would expect to do manual calculation for multiple linear regression as well as partial correlation, and maybe it's part of the factor analysis, because when we run for factor analysis, we share how to calculate the eigenvalue, how to calculate the percentage of variance explained, or something of that nature. I mean, if there is any need, I mean, based on what we have done in the assignment, then it will be suffice for you to work on your midterm exam. I mean, it's not something beyond what we have done in class, beyond what we have done in assignment. It is confined to what we have already discussed in the class session, as well as what we have done in our assignment. So that will be what to expect for section 2. I mean, the calculation plus interpretation for SPSS output. And what else? So, okay, when in dealing with the calculation as what we have done in 5950, you have to be precise. I mean, when you do your calculation, the answer for the calculation is not given as multiple choice, but the answer will be just like what we did for 5950. You need to plug in the answer for the calculation. I mean, let's say if you were to calculate for your F, I mean, you need to type in the answer. And you need to follow what is requested in the exam. Let's say within bracket 2 decimal places or 3 decimal places. I mean, you need to follow what is instructed in the question, right? Because if the question asks for round up to 3 decimal places, but your answer is only 2 decimal places, then of course it will not match with the model answer in the Google form. Therefore, if it is not matched, it's not the same, then it is considered to be wrong, even though your calculation is correct. but because it doesn't follow the model answer as expected or as required, then your calculation will be considered as wrong. So you have to be precise. That means while doing your calculation, make sure go to minimum of 5 decimal places. But the final answer depend on the question given in the exam. If the question asks for within bracket 2 decimal places, you run up to the 2 decimal places. If the question asks for within bracket 3 decimal places, then you run up the answer to 3 decimal places. Otherwise, unnecessarily, the answer is considered to be wrong. And because this is very crucial, because why? Because if it is sit in exam, your step, there are some point assigned for each of the step. But in this case, since we just look at your answer, so that means if your answer is correct, then you get full mark. If your answer is wrong, 0. That means either full or 0. That means there is no in between. That means it's very you have to be very precise in your calculation. Otherwise, unnecessarily the calculation is correct, but because of the form, the final answer, the answer is slightly different from the model answer, then it's considered to be wrong. Ya, susah hati pula Pak Izzah. Relax. InsyaAllah anak tu akan sihat. Dan exam pun insyaAllah akan berjalan dengan lancar, insyaAllah. Lagipun kita tak amat 17 ya. We have only 17 student in this class. And I hope that every one of our 17 members should be able to perform in the midterm exam with a high score in the assignment. And hopefully our final exam will be also the same thing. Then everyone should be able to perform in this 6953. Okay, any other question? That is basically what to expect for the exam. So the exam, you can open the formula sheet, but not to open the notes, right? And then you need to prepare the scrap paper for you to do the calculation. But of course, you don't have to show the calculation. You just need to enter the answer in the space provided, and that's it. Does that answer your question, Faiza? Your concern about the
Yes,
midterm
Prof,
exam?
thank you.
Okay, welcome. Inshallah, everyone should be able to perform without exception, inshallah. Provided that the keyword is we have done our assignment and we can do the assignment just referring to the formula sheet, but not to as I mentioned in 65950. If we were to follow what we have done in class discussion, I mean, if you were to open your notes, that means you don't test your understanding. But if you were to work on the exam, on the assignment based on the formula sheet, that means we are testing our understanding. I mean, when we come for the exam, it's just another reinforcement of your learning. That's it. But if you use, if you work your assignment using your notes, then I don't guarantee that high mark in the assignment will also lead to high mark in the midterm exam, inshallah. Everyone have the highest potential to perform, inshallah. Okay, are there any question about the exam? Of course, if you have any other question pertaining to the exam before next week, feel free to use our WhatsApp group and you can post your question. And every day, because I have placed the WhatsApp, our WhatsApp group for the class WhatsApp group in the top. It will be fixed. Fixed in my WhatsApp. So the first thing that I will look will be: is there any question from 5950? Is there any question from 6953? And that will be the first priority for me to entertain before I proceed to other WhatsApp group. WhatsApp group yang lain tu kadang tu apu je kan. InsyaAllah. All right, so if there is no question, maybe for today we stop up to that point so that you can have time to look through, but don't be too excited to work on your assignment immediately. Go through the notes, go through to the calculation. Once you get the understanding, then only you work on your assignment. Okay, for the assignment for multiple linear regression should be submitted this week, kan? This Sunday. You can admit this Sunday. So, but for your assignment, for partial correction, if you want your assignment to be graded before the exam, on Thursday, then please submit your assignment before on or before Wednesday. So that I can mark your paper and I can share your score Wednesday night. The next day will be Thursday for the exam. At least you know how you perform in your assignment if you want to get your assignment marked for partial correlation. Otherwise, the assignment is to be submitted the following week, inshallah, after the exam. Sunday after the exam. Okay? So, thank you very much, and for our Muslim brothers and sisters, selamat stay, selamat Hari Raya, maaf zahir batin. Inshallah, we still have many days for celebration because 30 days, right? 1 month, inshallah. Okay, so we call for the day for today. Today is quite early. It's slightly before 4 o'clock, inshallah. Then you work on your work through. And inshallah, if you have any question pertaining to the assignment, to your exam, feel free to post your question in our WhatsApp group, inshallah. Okay, Assalamualaikum warahmatullahi wabarakatuh, inshallah.
Thank you, Prof.
Okay, welcome.
Selamat Raya.
Okay, selamat raya, inshallah. All right.